This is the Global Infrastructure Resilience Index. My name is Gabriel Bernal, Chief Scientific Officer at Ingeniar Risk Intelligence and Technical Lead for the development of GIRI. The way any infrastructure system is impacted by natural hazard events depends on how exposed the system is and, more importantly, how vulnerable. When a hazard event occurs, there follows damage and destruction, preventing the system to perform as designed, reducing the offer of critical services to society. These impacts can be accounted for through probabilistic risk models, testing the capacity of any infrastructure system to withstand damage through the simulation of hundreds of thousands of feasible hazard events of different nature. But this is only half of the story. Once damaged, the system must recover to be able to restore the offer of critical services to supply the demand. How fast and efficiently the system recovers is a measure of resilience. But not only resilience of the infrastructure, but of the society that depends on it. Measuring disaster resilience of the infrastructure of the world is quite difficult, as it implies not only the global quantification of risk under a changing climate, but also sizing resilience capacities of countries and consistently combining all this complexity to inform decision and action on all aspects of development. This is done through the Global Infrastructure Resilience Index, or GIRI. GIRI is CDRI's first ever global infrastructure probabilistic disaster risk assessment and holistic resilience index. In alliance with UNDP, CDRI partnered with an international group of experts to develop the GIRI model and index with the highest quality standards and state-of-the-art models, making GIRI the most ambitious and complex disaster risk assessment modeling in the world nowadays. GIRI is quantified for all countries in the world. It covers risk and resilience assessment to multiple hazards, like earthquake, tsunami, landslide, flood, tropical cyclone, and drought. The last four with models that explicitly incorporate climate change through the definition of upper and lower bounds of future climate variation, in accordance with the most recent IPCC future projections. The infrastructure sectors included are power, highways and railways, transportation, water and wastewater, communications, oil and gas, and buildings. Each sector is represented in the model through its full collection of assets and elements, country by country, with novel pricing and physical vulnerability models. The combination of all these components renders the GIRI metric, presented here for 171 countries in the world. Beyond being a simple index, GIRI provides a full risk and resilience profile by country, very helpful for governments to understand their fiscal risk for all infrastructure sectors and to be able to inform and develop national resilience policies or strategies. Furthermore, GIRI provides a holistic view, transcending the actuarial and financial risk metrics into metrics of infrastructure resilience and its individual capacities. Useful for governments to diversify investment in risk management and climate change adaptation, referring to construction, operation, maintenance, and repair, among gray, green, and blue infrastructure, but also investments on the social, environmental, and economical transformations required to increase resilience. GIRI is versatile enough to allow for the verification of pertinence and effectiveness of risk management and climate change adaptation actions and plans. Through GIRI, it is possible to design a collection of risk management and climate change adaptation actions to achieve a target resilience level. This is, in other words, to evaluate the effectiveness of different risk reduction measures to make decisions about the optimal level of resilience. This is the Global Infrastructure Resilience Index. Thank you.